Hi folks, we're going to take a look at the solution to page 158, number 25. Okay, so the scenario here is that we have to build a rest stop along this highway between C and D. Okay, and these lines here represent a bike path coming from the two towns of Ancaster and Dundas, and we want to minimize the total length of these paths to this rest stop. Okay, now they gave us the diagram, so essentially they told us to assume that these bike paths were going to be exact lines, be straight lines to the rest stop. So this really is the simplest type problem you can solve of this type. Okay, so what we have to do is minimize this total length. Okay, so this total distance here, which is just going to be A plus D, is what we have to minimize. And again, the usual problem we have, we've got two variables here. Okay, but since it looks like I'm going to be working with these two triangles, it makes sense to take the information we have about the bases, which is that the total length is 8, and to split it up into two parts. So if I call this x, this will just become 8 minus x. Okay, and so now it looks like I'll be able to write each of these variables in terms of that variable x, which is my goal, to have only one variable. Okay, so looks like we can use Pythagoras for each. So a is going to be given by the square root of x squared plus 4 squared, so x squared plus 16. Okay, and d, it'll be a little more complicated, but I don't think we have much of a choice, is going to be the square root of 8 minus x squared plus 6 squared, which is 36. Okay, so here's our model, and now let's find the constraints on the variable. So, if x is 0, one path would go here, there would be the other path, or x could be, I guess, 8, and it does something like that. Okay, so it looks like x is going to live between 0 and 8, so we do have a closed interval here. Okay, so let's go ahead and take the derivative. So that's going to be equal to, so this is going to be 1/2 x squared plus 16 to the negative 1/2 times derivative of x squared plus 16, which is 2x. Okay, then here we've got 1/2 times. Now, I'm going to see if I can avoid actually squaring this thing. Who knows? Maybe I won't actually have to do it. So I'm going to keep it as it is. So we have 8 minus x squared plus 36. Oops, sorry, this should be in brackets here. That should be brackets. Forget that. To the negative 1/2. And now I need to take the derivative of this inside portion. Okay, so that's just a constant. It'll be 0. So here I have 2 times x, 8 minus x. Okay, times the derivative of 8 minus x, which is just going to be negative 1. Okay, so I know I'm looking for where my derivative is 0. So let's do some simplifying here. So 2's cancel out, so I'm just left with x over the square root of x squared plus 16, the denominator. And here, again, 2's cancel out. I've got this factor of negative 1 at the end, so this will end up becoming a subtraction. And so I've got 8 minus x is what's left in the numerator, and then this will go down to the denominator, so square root of 8 minus x squared plus 36. Okay, so we're seeing that this is, starting to be a bit of a complex, some more complex function to differentiate and work with, but I think we can do it. So here, while I would normally suggest subtracting these with a common denominator, I notice here something we've seen in the past. I got these square roots that I would really like to get rid of. Okay, so I think what makes more sense is to bring either of the both of these onto different sides of the equation, and then we can square both sides to get rid of the square roots. So I'll bring that to the other side, make it positive. So we have 8 minus x over square root of 8 minus x squared plus 36 equals x over square root of x squared plus 16. And now I'm just going to square both sides. Okay, and that'll get rid of the square root. So now we've seen this trick. This is at least the 3rd time I've done it in a video. Probably come up in some other problems. So definitely something you want to have at the back of your mind when you're solving these equations with square roots. Okay, so let's square the numerator here. So I have to square the whole thing. So 8 minus x times 8 minus x is going to be 64 minus 8x, negative 8x minus another 8x is going to be 16x, then plus x squared. Okay, divided by, well, the square of this thing, so the square root's just going to disappear. So I think at this point here, I might as well square this, but I've already done it because that's the same square as I took in the numerator. So again, I think it was worth waiting because now I know it's going to be exactly the same as the numerator, but plus the 36. So 64 plus 36 is just 100, so I'll have 100 minus 16x plus x squared. And the right-hand side looks like it'll be significantly easier. So numerator, we just have x squared. And then here, the square is going to get rid of the square root, so x squared plus 16. Okay, and well, we don't really have much choice here. We're going to have to cross-multiply. And I guess cross our fingers that this is something we'll actually be able to solve. Okay, so here, let me do this carefully. I'll multiply that one there. So x squared times x squared, x to the fourth. So let's see here. I've got a negative 16x cubed, and I think that's the only x cubed term I'm going to get, so that's not too bad. 16x cubed. Okay, I'll definitely have 2x squared terms because I got 64x squared plus 16x squared. So that's 64, 74, 80, so plus 80x squared. There's going to be only one x term, negative 16 times 16. So that's negative 256x. And then my constant term is going to be 64 times 16. I think that one I will take the trusty calculator for that one. 64 times 16. Okay, 1024. Actually, you know what? I should have done that in my head because these are both powers of 2. Should have been able to figure that out. Okay, so plus 1024, but it's a little late. Okay, other side luckily significantly easier. So x squared times x squared, x to the fourth. Okay, that's not looking too bad. X squared times negative 16x, negative 16x cubed. Okay, I'm feeling a lot better about this equation now. So plus 100x squared. And the reason why I'm feeling much better is that, hey, all the real ugly stuff, hey, look at that, just canceled out. Okay, I'm left with just a quadratic. So to keep my a value positive, I'll bring everything to the other side. So 100 minus 80, so 20x squared plus 256x minus 1024. I'm not even going to try to factor that here, so I'm just going to go straight to the quadratic formula. So negative 256 plus or minus. I'm going to take the discriminant right away. Just save myself the time. Okay, so here I have b squared minus 4ac. So I've got 256 squared minus 4 times a, which is 20, times c, which is negative 1024. Okay, and let's take the square root of that. Oh, look at that. It's a nice number. Okay, all over 2a, so all over 40. Okay, so again, just to make sure you know what I did, I just did the b squared minus 4ac on the calculator. So here, that one's definitely going to go because I want x to be positive. Okay, and so here, what do we have? I got to calculate that. So we have negative 256 plus 384 equals divided by 40. 3.2, and so it looks like that's 3.2. We got to make sure that this is indeed a minimum, or we have to check oops, sorry, there you go. We have to check all terms here. So I think that's what I'll do here. So we're going to check d total. We need to make it the smallest. So d total at 0 is just going to be, well, this is 0 squared plus 16, so that's just going to be 4 plus, and this is going to be 8 minus 0, so 8 squared 64 plus 36 is just 100. Square root of 100 is 10, so that's 14. Oh, sorry, I wasn't showing you. I was just didn't write that down. Okay, so now we'll check d at 3.2. That's d total. Okay, so I'm just going to stick 3.2. That one I'll need my calculator for. Okay, so square root of 3.2 squared plus 16. Okay, plus square root of 8 minus 3.2 squared plus 36. Is that off? So it looks like 12.8. So here that's 12.8. So far this one's the winner. And let's do the total at the last one was 8. Okay, so actually that's pretty nice because 8 squared is 64 plus 16 is 80. So here we got square root of 80 plus, and here 8 minus 8 is 0, so that just goes. We just have the square root of 36, which is 6, and 14.9. So in the end, 14.9. And so this, the critical point, is the one that has the minimum value. Okay, now let's go back to our question and see what they're actually asking us. It says, where should the rest stop be built? So this is where we go back and we can give our answer, and we can say, well, X is what we found, which was 3.2. So it looks like it should be 3.2 kilometers from point C. So our answer here is 3.2 kilometers from point C. Okay, there you have it. So this is a bit of a complicated one. Okay, not so much because of the setup, but because of all the algebra. But you know, you're really starting to see, and these again are fairly simple problems, but you're starting to see that when calculus is actually put into practice, you know, it can get ugly. Okay, so that's it for this one.